Hello there, Year 5, and welcome to your maths lesson. So we are carrying on looking at fractions. So let's first of all have a look at our starter activity, which is to do with what we've been covering in the last few days. So here are some fractions cards. All of the fractions are equivalent. And then it's got some information. You've got 3 letters that you need to find out, but the main objective is to calculate the value of C. So have a look at that. If it looks a bit confusing, that's fine, but have a little go and then stick around for me to tell you what it is you need to do to work out the values. Okay then, so we know that we need to work out the value of C, but before we can work out the value of C, we need to know the values of A and we need to know the values of B. So we're going to look for the value of A first. And I'm going to use the information that I've got. Now, at the moment, the middle fraction, B over C, is not of any use to us. So on this slide, I'm actually going to cover it up. Now, I've got 4 over something is equivalent or the same as 20 over something, over 50. So I know from what we looked at yesterday that when we are finding equivalent fractions, whatever I do to the numerator, I have to do to the denominator. To get from 4 to 20, I have to multiply by 5. So something multiplied by 5, because I have to do the same to both the numerator and the denominator, has to be 50. Now I know that 10 times 5 is 50, so A has to equal 10. Now that can start to help me. So if I can change A on this slide to 10, now I also know that A plus B equals 16. Now 10 plus B equals 16, which means that B has to be 6, which means that on my next slide, I've got a bit more information. So if A is 10 and B is 6, let me just put another white square over the top of it so that I can hide that letter. Then I'm a bit closer to finding out what C is. Now, we do have a slight problem because 6 doesn't very easily change into 20 or into 4. Now, it might be that I could multiply by halves and things like that. But what I could also do is if I look at 4 over 10, I can actually simplify that because I can divide both of those by 2. So 4 over 10 is the same as 2 over 5. So that's another equivalent fraction. Now, if I have a look at what I need to do to 2 to get to 6, I know that I need to multiply 2 by 3, which means that I have to, oh, that's not what I was meant to do. I have to do the same to the denominator. So 5 times 3 is 15, which means that C must also be 15. So there's a few different steps in that. You need to use some information that's not on the screen straight away, but well done if you manage to find that C equals 15. So let's have a look at what we're looking at today. So we know that fractions represent part of a whole, but sometimes fractions can be used to represent more than a whole, and that's what we're going to be focusing on today, and I believe tomorrow as well. So here we have a whole. And I've split it into sevenths, and a whole is equivalent to 7 sevenths because all 7 of these different parts would be shaded in to make a whole, which gives me 7 sevenths. So here we've got 2 wholes, and I'm going to split both of those wholes into sevenths again. So I've got 7 sevenths here, 7 sevenths here, which means that added together, that is 14 sevenths altogether. We can see normally the numerator is a smaller number than the denominator, but this time the numerator is a larger number than the denominator. So let's imagine that both of those wholes are chocolate bars. So there's 2 chocolate bars split into sevenths. So they're both split into 7 equal parts. So we're going to imagine that it's mine and Mr. Arnold, or Mr. Arnold and I have got a chocolate bar each, and we're both eating different amounts of it. So Mr. Venton is eating 2/7 of his chocolate bar. Mr. Arnold is eating 3/7 of his chocolate bar. So we should be able to work out that Mr. Venton's got 5/7 left and Mr. Arnold has got 4/7 left. Now, if Mr. Arnold then started to feel a little bit upset that Mr. Venton had more chocolate than him and said, oh, let's put our chocolate bars together, we could work out how much chocolate was left altogether by adding 5/7 and 4/7. Now, we talked a little bit about this in Morning Fluency, where we've said that it's like as if we were adding marbles. So we know that it's still in sevenths at the bottom because the denominators are the same. So that is fine. And then 5/7 add 4/7 gives us 9/7. So hopefully when we look through it, we can see that we've got 9/7 left. Now, when we compare that to a whole bar of chocolate, I can see that I end up with more than one bar. Now, the reason that it doesn't end up like this is because that is larger than one whole. My whole chocolate bar has been split into 7/7, which means that as soon as I've got more than 7/7, I need to start on a second whole. 9/7 could also be said as one whole and 2/7. So we've got improper fractions, which are where the numerator is larger than the denominator, and we've got mixed numbers, which is a combination of whole numbers and fractions. So let's have a look here. This isn't chocolate anymore because it's luminous green, but how many quarters are here altogether? So we can see that we've got 1, 2, 3, 4. So each whole has been split into 4, which means that each whole has been split into quarters. And I've got 4, 8, 12, 13 quarters shaded in. So we can write that as 13 over 4, because each whole has been split into 4 equal parts, and we've got 13 altogether. Now, if I have a look at how many wholes we have, we've got 3 wholes and then 1 quarter. So that's how I can write it as an improper fraction and as a mixed fraction. A fraction rule can still be helpful for this as well. So I'll keep putting up that as a link so that you can use that and refer to that. The denominators will help you as well to see how many it's been split into. So the denominator shows us the number of equal parts that the whole is split into. If the numerator and the denominator are the same, then the fraction is equivalent to a whole. So if I've got 3/3, then 3 of the 3 parts have been shaded in, which means that they've all been shaded in, which is the same as a whole. So if a numerator is greater than the denominator, then it must be greater than 1. So if I've got 5/3 shaded in, 3/3 is the same as a whole. So anything larger than that means it's going to be 1 and something. This is different to 5/6, which is less than 1. So if I move this one across to compare them, if I can see that that is 6/6 is a whole, which would be the same as 3/3. But in this case, I've got 5/6 shaded in. 1/3 is bigger than 1/6. So 5/3 is larger than 5/6. So now it's your turn to have a go. There's 3 different levels of activities. Hopefully you will be able to access as many of them as possible. If you're not sure and if it is confusing, please do go through the video whilst you are working on your activities. That's what these videos are here for, and it's a real benefit of home learning, because in school you wouldn't necessarily be able to do that. So please do use the videos as a sort of step-by-step guide whilst you're working, instead of just rushing into it and guessing. But good luck with it. If you need me to show you it in a different way, please do let me know, and I'll see if I can send over some links to different perspectives of it as well.